Hello? All right, awesome. Hi, welcome back to day 2. I'm glad you decided to join me today. Let's jump right in. I'm going to talk to you guys about a web development framework called LiveView and how it's beginning to, and I think it will continue to drive the adoption of Beam programming languages, Beam being the Erlang VM, as well as keeping functional programming relevant to web development. Before I tell you a little bit about myself and before I tell you all about LiveView, I'm just curious, anybody here ever used LiveView before? 3 people. Any Elixir developers in the audience? The same 3 people? Any Beam programmers? Anyone on the Erlang VM? Okay, the same person. All right, so you guys are a little bit new to LiveView, which is great because this talk is absolutely designed for and aimed at you lovely folks, people that are curious about this framework, maybe want to know what it's going to bring to the functional ecosystem. We're going to look at a little bit of code, but I'm going to keep it high level, hopefully just to sort of sell you on the benefits of the LiveView framework and what's so valuable about it. We're not going to get too far into the weeds. Okay, hi, I'm Sophie, which you may already know because you're here and you came to see me. A little bit about me, I'm the co-author of the Programming Phoenix LiveView book, which is out in beta from Prague now, together with Bruce Tate. The co-host of the Beam Radio podcast, together with some very wonderful folks. I'm a staff engineer at GitHub, where we don't use any Beam programming languages, and we certainly don't work with LiveView. But if you want to complain to someone about Azure Event Hubs, you can come find me after this. And I am the owner of this dog, who is very normal, and he can be found doing normal things, like sleeping on the arm of the couch in a very normal shape. And I will add, by the way, that if you ask a question today and give me your email, I'll give you a free copy of my book because I have some to give away from the publisher. So keep that in mind. All right, what are we going to do today? Why are you here? We're going to talk a little bit about some of the common problems that really all web developers face, that all web development frameworks face. I'm going to show you how LiveView solves those problems. And like I said before, we're going to take a little bit of a look at some code just so that I can really drive home what I believe to be the elegance of some of these solutions. We're not going to require some sort of deep Elixir or deep LiveView knowledge to get something out of this talk. We're going to go through what LiveView is at a high level, how it works also at a high level, and I'm going to hopefully explain to you very persuasively and convincingly why it's going to drive Beam adoption, why we're already seeing it drive Beam adoption, and as a result, why I think it's going to keep functional programming languages relevant to web development. All right, something you already know if you're here in Copenhagen today, you probably like functional programming. That might be something that resonates with you. You might already know about and love working with the Beam if you're one of the 3 people that raised their hands at the beginning of this talk. But you might not know about LiveView. I think we've established that you probably don't know that much about it, which is why you're here. So we're going to take a big step back before we jump in, and we're going to answer this question: what is LiveView? So LiveView brings the power of functional programming and the Beam to web development. It is simple, it is a declarative, and above all, a functional web development framework. So how does it work? LiveView is basically a process. Even if you're not familiar with the Beam and working on the Beam, you're probably familiar with a process. It spins up, it receives events, it holds some kind of internal state, it updates that state in response to user interactions and other types of messages, and then it renders that state on a web page for your wonderful users. So a LiveView state is maintained in a functional and immutable Elixir data structure called a socket. So you will hear me say the phrase socket when we take a look at some code later. That is where the state of the LiveView process lives. It makes client-server communication simple because of its functional and declarative nature, because it maintains this immutable state in the socket structure. It's pretty easy to work with, and it vastly simplifies what can be a very complex dance between the client and the server. I want to talk a little bit about the LiveView lifecycle, how this process-based communication works. Phase 1 is very normal. If you have ever built a web page, you are familiar with phase 1. Your app receives a regular HTTP GET request. Your user sits down, they open up their computer, they type some address for your web app into the URL browser bar, they hit enter, that's a GET request, your app receives it, and a web page is rendered. Not quite end of story, because then there's phase 2. Once that web page is rendered, that's really where LiveView takes over. The LiveView client-side code will send that WebSocket request for you as soon as that page loads. It's going to open up and maintain this persistent bidirectional WebSocket connection. And over that connection is where all of the LiveView communication flows. Your LiveView process running on the backend will receive an event up from the client over that connection. It'll do something to update that state that it's storing in the socket. In response to that, and anytime the socket state changes, LiveView will automatically re-render the page for you very, very efficiently. Only a teeny tiny bit of that page will update depending on whatever it is that has changed in the LiveView state as represented by the socket. This is pretty much what LiveView looks like, and it really is as simple as that. Picture this circle as the WebSocket connection itself. You have the client JavaScript code that you didn't write. This is all LiveView framework hanging out on the front end. You've got your LiveView process running on the back end. Client sends an event up to the server because the user, let's say, clicked a button. Process state updates. Some small diff is sent down to the client again, and something changes on the page. And it's really just that simple. So what's so great about this? It sounds simple, but it also feels like it could be complex if you were responsible for writing like any of the code that supports this lifecycle. But that's the beauty of the LiveView framework. It really handles all of those details for you, and you get a lot of benefits from this. So it optimizes for developer productivity because you and your team get to keep their brain firmly on the server side. You don't have to write JavaScript code. I say you don't have to write, not you'll never write, because you can still integrate custom, sophisticated, fancier little bits of JavaScript to get those really nice interactions that your users may require. But that sort of tedious boilerplate, how does the client send a message to the server? How does the server respond to the client? How does the client act on that response by updating the page? All of that is handled by the LiveView framework itself because it is very declarative. You never have to tell LiveView how to do something. You'll only ever tell it what to do. And we're going to see that in action in the rest of this talk. So that means that you get to write pretty much pure backend code. Pure functional Elixir code on the back end. You don't have to do this complicated coordination between maybe your front end team and your back end team. You don't have anybody writing up a real quick API spec so that they can get it to the front end team so that they can hopefully build a bunch of React components that align with that spec. You don't have to deal with complicated JavaScript testing frameworks. You don't need an onerous release cycle where you're trying to coordinate the back end changes and the front end changes, because you're really just writing Elixir code on the back end to get a fast, interactive, real-time, single-page application. You don't have to write code that manages concurrency or builds resiliency because LiveView is written in Elixir. It is running on top of the Beam. Even if you're not super familiar with the Beam, you're probably a little bit familiar with the concepts of fault tolerance and concurrency, and these are things that are baked into the Beam for free. So you don't have to write code that takes advantage of them. Your LiveView is resilient. If it crashes, it'll start right back up because your Phoenix web application is supervising that LiveView process, and it'll just kick it back up for you. You can massively scale up your web application in a huge distributed system with ease because the Beam allows for that. So you get all the benefits of the Beam without having to actually do anything in order to unlock those benefits. What else? As I said earlier, you don't have to manage the details of that client-server communication. The framework does all of that for you. And you don't have to write tedious JavaScript. And I really do want to make this distinction because when LiveView first came out a couple years ago, all of us Elixir developers who tend to be very back-end focused were totally ecstatic because we felt like we were finally freed from front-end web development. And in a sense, that's true. We don't need these cumbersome front-end frameworks anymore in order to get these really sophisticated, really interactive single-page applications. You don't have to write that JavaScript boilerplate that sends messages to the server, responds to the payloads that it gets back, and actually makes those changes to the page. But that doesn't mean that you can't integrate the sophisticated JavaScript that your users might require. LiveView makes it easy for you to do that. There's a set of features that will take a brief look at later on in this talk. So you don't have to write the boring parts of JavaScript, but you can still meet the demands of your users in your single page app. All right, so as a result of all of these wonderful benefits that I've totally convinced you of, LiveView adoption has really been encouraging. I would say that it's really become the standard for web development if you're already working with Elixir, if you're already working with Phoenix. So we've got companies that are already using these languages and this framework who are reaching for LiveView now as a matter of course. I have seen lots and lots of smaller consultancies that may or may not already be working with Elixir beginning to reach for LiveView because it makes their small teams extremely productive when it comes to spinning up web applications. And it's also very often used when you need to solve internal or like admin tooling problems where the barrier to entry for LiveView is very low. You have a problem that you need to solve internally. You don't necessarily need to sell your whole organization on a brand new framework because it's an internal or an admin tool. It's kind of an easy answer. So let's see, companies like Dockyard, Alembic, Cars.com, folks that are already using Elixir are certainly using LiveView today. And we have begun to see LiveView, I think, drive Elixir adoption a little bit. I believe it's Spotify a couple years ago, although I don't know where they're at with it these days. Spotify began using LiveView, and I think that was their entry point into Elixir and into the Beam ecosystem. So we're beginning to see a little bit of this type of adoption being driven by the compelling case that LiveView makes for web developers. But adoption, I think, outside the Elixir community is slow, which, is not surprising. But I want to really dig into what's standing in the way. We're going to move on now. We'll talk a little bit about what these common LiveView adoption blockers beyond the Elixir and the Beam community are. I'll show you how LiveView knocks them down and where does that leave us next. And I'll hopefully argue that it leaves us poised for much wider spread Elixir and Beam adoption through LiveView. All right, so what are some of these common blockers? And really, these are not necessarily specific to LiveView. These are the common challenges that I think any web developer, any web development framework faces. And LiveView has a neat, a beautiful, and elegant solution for every single one of them. All right, going through this list, and then we're going to dig in a little bit greater detail. We're going to talk about security challenges, state recovery, file uploads, code organization, integrating JavaScript, and efficient data transfer. And then I dare you to tell me that any framework that solves for all of these is not a very compelling choice. All right, so securing your LiveViews. What is the problem with security in LiveView and more generally? So one of the reasons why LiveView is so great is because it's very fast. It's an extremely snappy user experience. And one of the reasons why this is true is because LiveView optimizes page load times with live navigation. And the way it does this is by reusing the WebSocket connection when you're navigating between different LiveView pages. That shaves off a little bit of time and users notice it. But what this means is that there is no new HTTP request if you're live navigating between different LiveView pages, which means that the router of your application could be skipped entirely when you're performing this type of live navigation. So what that means is that the place where most of your auth logic lives, which is the router, didn't get visited when somebody navigated between two LiveView pages, which could be a problem. Certainly could be a security problem. But it's not just a LiveView problem. LiveView encountered it very clearly because of this particular type of optimization. But there is absolutely a more general problem around how we secure any single page application and take advantage of the efficiency of WebSockets. LiveView has a solution for it. It is called Live Sessions. The LiveView framework provides this tool. Live Sessions let you really easily share any type of auth logic between a group of LiveViews while still allowing you to take advantage of this live navigation where you reuse that WebSocket connection and get that really fast page navigation experience for your users. We're going to take a little bit of a look at some code. We're not going to get too detailed, I promise. So here's your Phoenix router. You are grouping together, let's say, some admin routes that are all LiveView routes. You use this live session block, and you say that on mount, which is when a LiveView process initializes, we should invoke a module called user auth live. And let's go look at that module now. This is where we can put some auth logic. We can look for a current user, and if we find one or not, we can pop it into the socket, which I told you guys earlier is where the state of our LiveView process lives. And then we'll do some checks. If the socket has a current user, we'll return this continue tuple. And if it doesn't, we'll return this halt tuple and we'll redirect. In this case, we're redirecting to the root path. So even if you're not super familiar with Elixir, this code I think reads really nicely, which is, by the way, one of the benefits of Elixir. It's very idiomatic, very eloquent. Another thing I want to point out here, which is one of the advantages of reaching for a functional language for web development, is you get these really nice pipelines of code. So the socket is this immutable functional data structure, and the assign function is the reducer that you'll call again and again to annotate or update the state of that socket. And we can pipe our socket through chains and chains of smaller reducer functions that annotate or update that state in a little specific way. And this is just one example of a pattern that you're going to see again and again. If you're looking through LiveView code, you'll see the socket and the assign function being used to change the state of the socket, which is the state of the LiveView. That's just a nice little benefit, I think, of working with a functional language, and we get to bring that elegance, we get to bring that simplicity and that immutability into web development with LiveView. So in any case, we've got a pretty straightforward module with one function in it here that contains some auth logic, and we've provided an instruction in our router that any set of live routes grouped within this live session should always have this logic invoked whenever a LiveView starts up, whether you were live navigated to it over that shared WebSocket or not. So again, we don't have to teach LiveView how to do the sharing of that logic. We didn't have to write any code that tells LiveView this is where and when you invoke this shared logic. All we had to do was add one line of code into our router to say this is the shared logic for these routes, and then we had to find the home for that shared logic, which is in the module that we specified. That's pretty much it. We just had to tell it what to do, not when to do it, and not how to do it. And this, again, is the really declarative nature of LiveView. Keeps things really simple for us. The framework handles the hard parts, the tedious, the repetitive details, and it exposes to us as application developers the levers that we need to pull to implement the specific logic for our application to solve the needs of our users and our organization. All right, so we've handled security. We're totally convinced it's the right solution for securing our single page application. What about state recovery? What about when connections are spotty? What about when a user has filled out 99 steps of your 100-page form and then their router cuts out? How absolutely tragic. If they would have to go back to the beginning, they would be very upset with you. So this is a problem. What happens during a deploy? What happens if the LiveView process terminates for any reason, loss of connectivity, and so on? Until, actually this is a little out of date, until maybe about a year ago, the state of that LiveView would have been lost. But LiveView has had several solutions for this problem in recent years and months. We wouldn't want to see this happen. We wouldn't want to see form fields emptied, for example. I personally get like so frustrated when something like that happens if you're filling out a complicated form. And again, this isn't just a LiveView problem. How do we manage persistent state in our single page apps when a connection is lost? LiveView has a solution for this too. It actually has like 5 solutions for this that you get to pick and choose from. So LiveView has a feature called auto recovery, which guarantees that the form state, if you have a form on your page, is restored if the LiveView disconnects or crashes or is terminated for any reason. So when a LiveView connects initially, the LiveView JavaScript framework will execute any Phoenix change events that you've embedded on your page. Phoenix change events are little bits of annotation that you can add to any HTML element, like a form field, for example. And what those annotations do is it tells LiveView to send a message over the WebSocket connection to the LiveView process running on the server, and it sends that message with whatever data may have been present in the form field. These Phoenix change events are how form data get to the server when the user is filling out the form the first time. As long as that content remains in the form field, if the LiveView disconnects and reconnects, you'll get that same behavior running for you again for free. Your form state will automatically be recovered on the server. So you get form recovery for free. You don't have to do anything. You don't have to change anything. The way that you've coded your template to handle a user interacting with the form automatically gives you form state recovery. But you might need more than this, and you can certainly have it. There is another annotation you can add to your form or a form field or any element on your HTML page. It is the Phoenix Auto Recover binding, and you can trigger custom events to fire when the LiveView process mounts or starts up on the back end. If that's not enough, you have another option. You could also restore LiveView state from the client. You could knock down all my waters. You could put the state from your form into like local storage or client storage in the browser. And you could use this feature to tell LiveView, please take the state out of the client when the LiveView starts, send it to the LiveView process running on the server, and you can tell that process, take that state and put it in socket assigns. So we're going to break that down. So you would put your state in local or session storage in the client in your browser. You would add a little bit of code to the only tiny bit of LiveView JavaScript that is exposed to you as a developer that says, take the state from local storage, put it in some params. And then this is pretty much what that looks like in your app.js file that is generated for you when you begin a new Phoenix LiveView application. You get this file and it has like 4 lines of code in it. It looks something like this. You could add this key to those params. You could say, let's add a restore key. We're going to populate it with something that I pulled from session storage. And we're going to say that when the live socket initializes on that second snippet of code there, let's add those params into the mix. And then the very last thing you have to do is just tell your LiveView process when it starts up, use those params, put them in the socket. And that's going to look something like this. Your mount function is a callback function that you implement in your LiveView module. This is one of the very first things that gets called when the LiveView starts, when a user visits your web page. All we're doing is pulling those that data out of the params and using it to populate the socket, which becomes the state of your LiveView. So with like 3 lines of code, yeah, you get very sophisticated state recovery from the client that you have a lot of control over. So with the auto recovery that you get for free, LiveView handles, I would say like 90% of your state recovery needs. And if you need more than that, you can leverage the custom recovery events, or you can use this client state restoration pattern. So LiveView takes care of 90% of your use cases and gives you the tools you need to solve the other 10% if your needs are a little bit more custom or a little bit more sophisticated than that. And that's a pattern that you're going to see again and again in LiveView. The framework handles 90% of the problems that you need to solve, and it provides the means for you to solve the other 10% if the requirements of your application require it. Okay, so let's move on to the next common web development problem that LiveView solves, and it's file uploads. What's the problem with file uploads? They're hard, and they're pretty much required by any average web app today. I would be hard-pressed to find a web app where you don't, at some point, maybe need to upload a file. You're posting a tweet, and you want a picture of this fabulous conference. You're uploading a file, and so on. But like I said, they're hard. There are a lot of pure JavaScript code plugins, let's say, that you could use, more complex backend solutions. It's an everyday problem that can sometimes require you to write a lot of boring, complicated code, which LiveView absolutely has a solution for. So again, not just a LiveView problem, it's complicated and common, and we often have to reach for these third-party JS dependencies that can be kind of a pain to incorporate in our applications. So LiveView provides an upload API that supports interactive either direct-to-server or direct-to-cloud file uploads, and like everything in LiveView, it's very easy to work with. 3 steps here. You're going to, when your LiveView process starts up, in that mount callback function that we saw earlier, you're going to provide a simple instruction to say, we're going to upload some files. Here are the spec for those files. Maybe they can only be JPEG. Maybe they need to be a certain size, and so on. And this is what that looks like. You use the allow upload function. In this case, I'm saying that I'm going to allow an upload called cover image, and it can be a JPEG. You can provide more requirements or restrictions on that, but this one is pretty simple. What does this do? So LiveView tracks uploads in the socket as soon as you call this function. It tracks them in a key in your socket state called uploads. And then LiveView will automatically validate uploaded files against the spec that you provided. So you're not going to have to write any code yourself that says, let me check the content of this file upload. Is it a JPEG? Is it the right size? you told LiveView what your spec is. You don't have to tell it how to adhere to that spec. It's going to do that for you. What else can we do with uploads that are now stored in your socket state? We can render errors, we can render progress, we can render image previews. Let's take a little bit of a look at that in a moment. So we tell LiveView what we want our users to be able to upload. Then we're just going to attach the right form field to our form. Looks something like this. We've got a form and we're using the live file input function. This would be in some HTML template. And you're saying that this is going to be the file upload for that cover image upload that I told my LiveView to validate. That's pretty much it. You could also do a drag and drop with the Phoenix drop target attribute, and then bam, you have drag and drop upload capability. What else can we do? As I said, you can display an image preview. Here's some more HTML. We're going to use the live image preview function. That's it. You've got an image preview. You want upload progress? You got it. All you need is to call entry.progress once you iterate over the cover image uploads that might be available in your socket. You can also display upload errors pretty easily. Once again, we're taking a look at all the entries in the uploads cover image, and we're displaying an error for it. Pretty simple, pretty straightforward, a handful of lines of code. We have enabled our LiveView to take file uploads, to validate them. We've given the user the ability to click a button to attach a file or a field to drag and drop it into. And with like anywhere from 1 to 3 lines of code, you can display an image preview, progress, and any upload errors. Pretty straightforward. The very last piece of the puzzle is you have to tell your LiveView, this is how I want you to save the files that are uploaded. That's really the only bit of complexity, and that all has to do with the specific needs of your application. Are you uploading them to S3? Are you putting them in local storage, and so on? So you would have an event handler for the save event that would get sent from the client to the server over the WebSocket connection when the user submits the form. And the socket is going to have all of the upload entries because you told it to. So I've got this helper function here called do consume uploaded entries. It calls consume uploaded entries, which is provided to you for free by the LiveView framework. You don't even have to do the work of drilling down into that socket struct and pulling the uploaded file entries out of it. You just call consume uploaded entries. It's going to yield each entry to you, and you can put some custom logic in there. I'm calling a save upload function that's not pictured here. As I said, imagine you're sending them to S3. Imagine you're putting them in local storage. Totally up to you. So again, this pattern really emerges. LiveView handles all the hard parts. You just have to tell it what you want to upload, give the user a form field. The only code of any complexity that you need to write is the code that speaks to the specific needs of your application. Where do you want to store file uploads? So the framework handles the hard parts. It's given you this really elegant API. You just only need to write the code for your own application's uploading needs. And that's it for file uploads. Again, handful of lines of code, you get a very, very powerful file upload feature. So what about code organization? One of the things that always kind of stymied me the most when I was working with React, which was probably like 7 years ago, so maybe this experience is a little out of date, but there's just so much code. There's so many nested. I've seen these React files that are like super, super long. You've probably seen them too. And then they start to form a really big arrow going this way because you're nesting lots and lots of HTML. You're nesting lots and lots of little bits of JavaScript code that are all working together to build that single page application. And that's the problem. LiveView has this problem too, where it can. LiveView modules, which represent those LiveView processes on the back end, can grow to handle lots of events if you have a lot of interaction going on that page. So the templates that go with those LiveView modules can encapsulate a lot of markup. So there's no reason why you couldn't get really gnarly looking LiveView templates and LiveView modules that kind of bring those same pain points of a more traditional front-end framework. But again, not just a LiveView problem. The question really is, how can we compose UIs that are clean and maintainable, even when we have these really complex single-page applications that support a lot of user interaction? LiveView has a solution for that. And it's components. There are 2 types of components that you'll build into your LiveView applications. You'll use a live component when you need your piece of that particular page to handle some sort of interaction. And you'll use a function component when you're wrapping up reusable static markup. Then you'll use what I consider to be a very ergonomic component rendering syntax to compose these UIs together, kind of like you're building a beautiful puzzle. We're going to take a look at a brief example. So here is an app that I built for the purposes of this talk, and it's a library browsing app. And there's not a lot going on this page, but it's not super simple. We've got this index of books. We've got this kind of complex search form. We're showing and hiding it. We've got our header and our little menu on the top there. So it could be really a lot of code that supports even a relatively simple UI. But LiveView makes it easy to keep it organized. We would have our books index, we would layer into there a search component, and within that we'll have a separate component for the search icon itself. So we'll render the search component, which is a live component because it's going to handle the event that gets sent when that user submits the search form, and that's going to end up on that index template. And this is the syntax for rendering it. It's kind of ergonomic. I think you do have to give it, or you can give it, many bits of data to do its job, in this case the job of searching for books and handling the event to search for books. But simply you call live component and you give it the name of the component you want to render, and you give it some data that it may need to operate. That live component is going to handle all the search form events, so we have an encapsulation for the behavior of the search form. And this component's template will render that search icon, which is a function component. It doesn't need to handle any behavior. It just needs to sit there and show you a little magnifying glass. And that's all that it does. So you would have your index template. It would render your live component. The live component would handle the behavior of the form. It would handle the events that get sent when the user actually searches for books. And it would render the search icon for you. Putting it all together, that entire UI, which was fairly complex, can be summed up with just kind of 3 pieces of a diagram. It's pretty simple. So LiveView components give us the tools that we need to organize our LiveView and compose these layered UIs that make it easy to maintain. There's a home for the behavior of the form. There's a home for the markup for the search icon, and so on. We took a really brief look at a function component. I told you that the search icon itself was a function component. Function components are really powerful ways to wrap up common and reusable markup in a manner that can actually be highly dynamic. And the reason that you can make them very dynamic is with a pretty cool feature called component slots that we're going to take a brief look at now. Another example, what if we needed a function component for rendering a Bootstrap style card? We're going to define the function component that renders some provided content into the specific slots of the card. It's going to look a little bit like this. We've got a module, it's called card component. It uses the Phoenix component behavior and it implements a function called card. That card function is the function component itself. It returns some markup represented by that sigil H, the hex symbol. That's where we'll put our HTML. This is what it is going to look like when we're done. We've got a bunch of HTML markup. It's using some, I forget, maybe Tailwind styles to make something that looks like a card. And you can see here, what I want you to pay attention to is that we're using this render slot function to render some content into this header div, to render some content into this title div, and to render some content into the text div. So what is that content and where did it come from? I'll show you when we call on the component. So we've got our opening and closing component tags, and we're passing in, I think in this case, a book review. It's what we're going to render in the card. Then we call on our header slot. Everything in between the opening and closing header tags is the content that the card component will render when it called render slot for the header content. We're going to render the title in the same way. We're going to render the body in the same way, and we're going to end up with this extremely beautiful card component here, list of book reviews by the characters from 30 Rock who definitely read the book. So component slots allow us to dynamically render any given piece of content into the function components markup. We get these really easy to use, very reusable pieces of code that render really beautifully and that are really easy to use. And I think they are ergonomic, right? Even if you don't know anything about LiveView, so even if you're you guys, you can pretty much look at this and understand that inside a card, we've got a header, a title, and a body. It reads pretty nicely. It reads like English. All right, integrating JavaScript. I promised you earlier that you didn't have to write JavaScript, but you get to write some JavaScript if you want to, if you need to, and it's not a pain in the butt. So what is the problem here? Integrating custom JavaScript can be challenging and messy. It can certainly be, or was challenging and messy in LiveView when LiveView was a newer framework. So that meant that earlier on in the life of LiveView, needing a lot of complex interactions, needing a lot of JavaScript would actually drive people away from LiveView. So simple UI interactions like toggling something, showing and hiding a modal, let's say, the easiest way to do that in LiveView up until like a year ago would have been to round trip to the server to update something in that socket state that determines whether or not a particular element on the page should be shown or hidden, which is kind of a bummer. That's kind of the benefit of JavaScript is little things like showing and hiding an element can happen purely client side. You don't have to do that expensive WebSocket communication, although it's not that expensive, in order to do those simple interactions. But again, this isn't just a LiveView problem. How can we get these sophisticated interactive UIs that our users really demand today without the tons of complexity that come with a lot of modern day JavaScript frameworks? There is a solution, of course. LiveView has it. There is a feature in LiveView. It's called JS commands or JS bindings, and it allows us to execute these kind of quotidian, everyday utility operations like showing or hiding something fully on the client. You don't have to round trip to the server, but you also don't have to write your own JavaScript. Again, the declarative nature of LiveView is such that we're going to tell LiveView what JavaScript to execute, and it's going to do it for us. Okay, so the JS bindings provide this JavaScript command interface for LiveView, the declarative interface through which we tell LiveView what to do, not how to do it. You can also integrate this feature with another LiveView feature called JS hooks, which allows you to write your own more complex JavaScript that can fire in response to particular user interactions like clicking a button, scrolling to the top or bottom of a page. So you really get the full ability to integrate any custom JavaScript that you want. LiveView provides the places that you would slot that code in. But I want to take a look at a simple example for JS bindings right now. So I showed you this earlier. You click the little icon and it shows a form, and then you click it again and it hides a form. Simple enough, even easier in LiveView. You don't have to write a line of JavaScript to make this happen, but this interaction is executed fully on the client. We do it with the JS toggle function, which toggles the display attribute of the HTML element that you add it to. Earlier, I showed you guys that search.icon function component that we would call in our template. Here is its implementation. I'm using some icon that I got from a place that I forget, and I'm attaching this Phoenix click element binding. We call the JS toggle function. We're saying we are toggling the element that has an ID of book search form. As you can imagine, our search form has just that ID. So now when the user clicks this icon, it tells LiveView add or remove the display attribute of the specified HTML element. All of that's happening in JavaScript. All of that's happening on the client, so it's fast, and you didn't have to write any of it. You didn't have to tell LiveView how to do that. You just had to tell it what to do, the what being show or hide the thing. So there are lots more JS commands available that wrap up pretty much all of the common interactions you can think of, adding or removing a class, showing and hiding an element like we just did, adding temporary transition elements for animation, and so on. These basic JS bindings let you handle common UI interactions purely on the client. You don't have to round trip to the server, and you don't have to write your own JavaScript. You can, but you don't have to. So again, LiveView is wrapping up these nitty-gritty details in the framework, wrapping up these kind of tedious, quotidian, everyday behaviors, and giving you the tools that you need to invoke those behaviors or add the custom functionality that you might need. JS commands can do a lot more than what I've showed you in that 2-minute demo. You could push events to the server in response to certain user interactions. You can dispatch events to the client and in response to that, execute even more custom JavaScript using JS hooks in LiveView. You can use the JS bindings to do things like implement infinite scrolling, which actually, thanks to a new feature that we'll talk about next and last, is even easier than it ever was. This really just scrapes the surface. There's a great demo project out there by Chris McCord, who is the creator of LiveView. It's called Live Beats. If you want to see all of these complex JavaScript interactions and all of their elegance in LiveView, definitely do check that out. Okay, very last thing, very last problem that LiveView solves beautifully for web dev, and it's transferring data efficiently. What is the problem? So managing large data sets in LiveView up until recently meant that you were either going to store a lot of data on the server, and you could also take advantage of this feature called Phoenix Update Append. That's another DOM element binding you would add to some element on your page. These were not great. Storing a lot of data server-side in your LiveView process's state is not cheap, and this Phoenix Update Append feature is a little cumbersome to work with, at least in my opinion. But again, this is not just a LiveView problem. The question is, how can we efficiently manage large data sets for our users in our interactive web applications? You've got a single page app, you've got a billion songs you want your users to be able to browse. It's a hard problem to solve, but LiveView has a solution for it. There is a new feature in LiveView. It is called LiveView Streams, and it lets us efficiently manage large data sets by detaching them from the server and telling LiveView to store them client-side. So storing a lot of data client-side sounds kind of scary and painful, but again, LiveView does it for you, and it exposes an API that you use to tell LiveView what to do with your large data set, not how to do it. LiveView knows how to do it. We're going to look at a brief example. So we're going to be looking at a chat application example. And the first thing we want to do is put a bunch of messages in the socket state so that they can be displayed in the chat room. So we'll be establishing what could be a very large data set in this LiveView stream when the LiveView starts up, when the user loads the web page for the chat application. We've got our mount function. That is a callback that's invoked when the LiveView process starts up. So a user visits the chat room web page, LiveView process starts, calls the mount function, and then we're calling the stream function. We're saying put into the socket a stream. It's going to have a key of messages. It's going to contain, in our case, the last 10 messages, could be the last 100, could be the last 1,000, could be the last million, totally up to you. Then all we need to do is render the content from that stream in our template. It's going to look a little bit something like this. We're going to iterate over the messages that we put in the stream and display their content. Pretty simple. So again, this was like 3 lines of code, and we are now managing data very efficiently on the client side. That data, those, in our case, 10 messages, are no longer in the socket state on the back end. They are embedded in the HTML only, and LiveView is going to use the DOM ID that we put on that element to manage it for us, this DOM ID right here. So this is a requirement of your markup when you're working with streams. But once we've done that, LiveView takes over from here. It's going to use that DOM ID to handle all of the insert, updating, deleting, overwriting, anything that you want to do with your stream data. So you're going to call stream function server side. That's going to update LiveView state in the socket with some instructions about what to do with the stream. Should I append a message? Should I update an existing message? Should I delete one? Should I delete all of them? And then LiveView is going to execute those instructions for you on the client. You don't have to write any of that code. You're always only telling LiveView what to do, never how. Quick look at the delete feature, brief look at some code to really drive this home. So let's say we've got a button on the page. For every message, there's a little delete button. It's going to send a delete event when you click it. Here is the event handler for the delete event. We find the message, we delete it, and then we call stream delete. We say, hey LiveView, can you please take this message out of the stream on the page? That's it. That is all you have to do. This one fraction of a line of code. This tells LiveView to re-render the page minus the message with this particular ID from the list that you had rendered in your HTML. It's pretty simple. That's it for deleting. All right. I've showed you a lot of things. We're going to wrap up and then we'll take some questions. So LiveView solves for some of the most common problems in web dev, especially when it comes to building these single page apps that need to be really interactive, that need to support real-time functionality, exactly the kind of apps that can get really complex to write when you've got client-side code versus server-side code. It solves for things like security, file upload, state recovery, code organization, JS requirements, and working with large data sets. That's a long list of problems that it has a nice solution for. LiveView wraps up the details to these problems in the framework and exposes simple APIs to you so that you can leverage those solutions and augment them wherever you need to. The declarative nature of LiveView handles the hard parts of interactive web development. You write only the application code that meets the needs of your application. The details of, for example, where to save an uploaded file, or a specific little snippet of JavaScript that you want to execute in response to a user interaction. You never have to write code that handles the details, for example, of client-server communication. So I think because of that, it's a really compelling solution for building these interactive real-time apps, not just for folks that are already using Elixir, not just for people that are already sold on the beam, but for anyone working in web development today. So we are getting close to 1.0 in LiveView. I think it's going to happen in the next few months. We'll see. I think we're going to see accelerated adoption. I think it's going to push beam adoption. And beyond that, I think it's going to continue to make functional programming relevant to web development. Because I think very often people reach for object orientation when they're building their web apps. They may reach for Rails. I think that's kind of still up there in terms of being a popular web development application. But this really brings those of us that are already sold on functional programming into the web development space, and it brings the benefits of functional languages into web development. That's it.